Good morning, Year 7. Right, today we come to the end of the section in the Waves topic on light. We're going to do a quick review of the light topic. So we're going to start by looking at reflection. So, reflection, as we've learnt, is all about how light interacts with a surface. Now in this case the surface is flat, and a light ray, once it hits a shiny surface, gets reflected off like that. And in order to complete the diagram, we have to add some labels, one of which is the normal line. Okay, now that normal line shows us the 90-degree position to the mirror. Okay, so that line is 90 degrees to this line. This angle and this angle are specific to this experiment. So here we have the angle of incidence, and here we have the angle of reflection. Now, the law of reflection, okay, so states that the angle I equals the angle R, the angle of reflection. Okay. Now, just for comparison, if we looked at what a reflection would look like from a rough surface, that's our rough surface, our angle of reflection is still going to be the angle of incidence. But in this case, because the position of the reflective surface continually changes, when we get reflections, we can have a reflection going that way, and we can have reflections going all over the place. Now that causes this light to be spread out. So the law of reflection still applies to this, but because the surface changes, the light gets scattered. So with a fixed flat reflective surface, all of the light rays are going to be coming out in parallel, which means we see a reflection. Here we don't see a reflection because the light gets scattered everywhere. Okay, but the same law of reflection applies. We then saw refraction. Now, refraction is all to do with the speed of light. Now, in the work we did, we looked at how a light beam interacts with a block of glass or perspex. And we saw that if we have an incident beam hitting the block of glass, we have a refracted ray and then we have another beam coming out of the block. Now if we put into position the normal lines, we will see that this is the angle of reflection, this is the angle of incidence, sorry, angle of refraction, not angle of incidence, and here is R as again, and here is the outward refracted ray. So the beam of light is doing that. Now the question is, why does it go at a different angle? Well, the speed of light changes. It goes very, very fast, and it's still going very fast. It doesn't slow down massively, but it slows down enough to change its direction. So in this case, we've got air here and glass here. This is a low density medium, and this is a high density medium. And when light travels from a low density to a high density, it slows down. Light goes slower in higher density than lower density. We see this as the light ray moving towards the normal. So in this case, the angle of I, which is this, is going to be greater than the angle of R, which is there. If the light goes from air to glass, once the light ray comes out of the block, it's going from a high density medium to a low density medium. So instead of going from air to glass, it's going from glass to air. And as a result, it's moving away from the normal. So this is reversed on the way out. Okay. The next thing we saw was about the spectrum and its dispersion of light. Now, dispersion of light occurs through a prism. We have a beam of white light that's composed of all the colours of the spectrum, and this white light gets refracted through the prism to different extents. And this then shows the colours of the spectrum. And if you remember, we said Richard of York gave battle in vain, and one of your tasks was to come up with your own saying to remember the correct colours of the spectrum. This red light here is refracted the least, and this is most. down here at violet. Okay. If we use only a single beam of light, like a laser, a single colour of light, then we only get one single beam out that is the same colour as the colour we've put in. It only happens when we're using white light. And white light is composed of red, orange, yellow, green, blue, indigo and violet. Okay. Now they're the three things that we've looked at within light. Today's lesson, I want you to do a summary mind map for me. So, the topic is going to be light in the centre, and I'd like you to segment your page into three like this, where I want you to put reflection, refraction, and dispersion in the three quadrants. Okay, and I want you to, in each third, draw a diagram and add a summary of each process that we've looked at. And the completion of the task is for you to take a photograph and post it in the comments below, please. Post it in the comments below. There are two further tasks for you to do. On the Firefly page, there's a set of summary questions and a novelty task for you to do as an extension. But I repeat that the completion of the task is when you've done a mind map like this and posted it in the comments. Okay, Year 12. Year 7. Thanks again. Bye-bye.